Good morning, students. Today we are here with a very new chapter of mathematics, that is areas of parallelograms and triangles. In this very chapter, you will learn about areas of plane figures, the fundamentals, including the areas of plane figures, and the theorems regarding the parallelograms and the triangles. Based on that, so far, as per the learning point of view, you must be knowing the formulas of the areas of parallelograms and the triangles. Here, the usage of formula is little less. However, the entire questions are based on the theorems. Alright, so let's start with areas of plane figures first. Two congruent figures have equal areas. Right? So what are congruent figures? First of all, we need to understand that. For congruent figures, we need to have two things in common. The first one is the shape and the second one is the size. Two figures are said to be congruent if they have equal shape as well as size. Right? So you have seen, in fact you have studied about the chapter based on congruent of triangles. Right? So in triangles, you have seen that when one triangle of equal shape and size overlaps with another triangle having the same property of shape and size, then the overlapping is perfect. It perfectly covers the second triangle. So let's take an example here. By the animation method, you can easily understand this. Simply, we see a triangle here. This is one triangle and second one is this triangle. So when the first triangle overlaps the second triangle, then we can say that these two triangles are congruent. So I'll draw one more time. So the first triangle here, when I try to overlap on the second one, it perfectly fits on the second one. So when it fits on the second one, we can say that the triangles are congruent with each other. So a circle with same radii can be congruent. A line segment having definite length, two line segments of the same length can be congruent figures. Next one is the diagonal of a parallelogram, divide it into two triangles of equal area. This also we have seen already. Parallelograms on the same base or equal bases and between the same parallels are equal in area. This thing we are going to cover in this particular class. This is the main important part of the this chapter. Triangles on the same base and between the same parallels are equal in area as well. An area of parallelogram is base into height when the height is given. An area of triangle is half base into height. This is the general formula of finding the area of triangle. However, the area of triangle on the basis of sides, we have equilateral triangle, we have isosceles triangle, we have a scalene triangle. For all these three triangles, the formula differs. For a scalene triangle, where none of the sides are equal, in that case we apply Heron formula, right? So median of a triangle divides it into two triangles of equal area. Diagonals of a parallelogram divides it into four triangles of equal area. So a parallelogram having two diagonals. Say this is a parallelogram, alright, and it has got two diagonals here, the first one and the second one. So suppose if we consider this as a parallelogram, then it divides the parallelogram into equal areas. We have four triangles. We got four triangles here. Triangle 1, 2, 3 and 4. Let us join this. Okay, so four triangles of equal area if it is a parallelogram. In case of rhombus also, rectangle also, or a square also, the thing are same everywhere. Right? So when we talk about the area of triangle, Here we have three types of triangle. The first one is equilateral. The formula for the area of equilateral triangle is different. That is square root of 3 by 4 a square, where a is the side of the triangle. All sides are equal. We have seen the proof in the virtual class also. So if you have any questions regarding the proof of this particular, like how do we get root 3 by 4 a square, you can ask in the virtual class. All right. Second one is isosceles triangle. Okay, this is for you as the homework. You can prove it. What could be the formula for isosceles triangle, area of isosceles triangle? And third one is a scalene triangle. So what is the area of a scalene triangle? This also can be proved. Okay, so basically in other chapter of class 9th, that is Hero's formula, we'll be learning about how to find the area of a triangle whose none of the sides are equal. Okay, in that case, what formula is applied there? That's all from today. Tomorrow, the topic will be fundamentals we have done today. Tomorrow we'll start with theorems of areas of parallelograms and triangles. All right, that's all from today. Thank you.